So these are according to the classification of magnetic material, these are the three major. We have other, but these are the three major magnetic material. And I told you that the classification is based on the response of this material when they are brought to the magnetic field. This is magnetic field. And I said this one called diamagnetic material will always be repelled. Any material that is being repelled when it gets to magnetic field, any material that is being repelled by the magnetic field, it is called diamagnetic material. So any magnetic material that is weakly attracted to the magnetic field, it is weakly attracted to the magnetic field, it is called what? Paramagnetic material. Any magnetic material that is strongly attracted to what? To the magnetic field, it is called what? Ferromagnetic material. So some example of diamagnetic material, some example let me say water itself is a diamagnetic material. Some other example we have under this one is silver, yes, gold. So I have silver, I have gold, I have water. All of them, when they are brought close to the magnetic field will what? Repel them. I told you what a repulsion means yesterday. Push them away. So the property of this one is that apart from being repelled by the magnetic field, the another property is that there is not going to be a magnetism in that material. So example of them, I say silver, gold. I'm giving you water as well. So when you take silver to the magnetic field will repel it. And when it is being repelled out of the magnetic field, there won't be magnetism again in the what? In the silver. When gold is taken to the magnetic field, it will repel. And when it is being repelled, there won't be magnetism again in the what? In the gold, and so on and so forth. Now, I've given you two properties of this. It is going to be repelled by magnetic field, and after the repulsion, those objects will not have presence of magnetism in them again. Now, this one, paramagnetic material. Any magnetic material that is weakly attracted, it is being attracted but not very strongly, weakly attracted to the magnetic field. They are called what? Paramagnetic material. And we have the like of magnesium, then the likes of aluminium, then the likes of, let's say, oxygen. Yes, oxygen. So I can remember these three for now. So when any of these three are taken to the magnetic field, you see that there is attraction between them and the magnetic field, but that attraction is very weak. So, and when they are taken out of the magnetic field, because of the weak attraction between them, they also will lose their what? Magnetism. So the same property shared by this. This one, there is total repulsion, and the material will lose their magnetism. This one, there is weak attraction, yet the material will still lose the what? Magnetism. So the third one, which is called ferromagnetic material. Any magnetic material that is taken to the magnetic field and there is a strong attraction between that material and the magnetic field shall be called what? Ferromagnetic. So I have the likes of iron, I have the like of steel, I have the like of cobalt. So all these examples I have mentioned are ferromagnetic material, and there must be an attraction between them and the magnetic field. So when they are removed from the magnetic field, they will not lose their magnetism. They still remain magnetized because the attraction between them is strong. It is only here the material lose the magnetism because the attraction is weak. Here too, the material lose their magnetism because there is repulsion, no attraction at all. But here, there is a strong attraction between those materials, that is iron, steel, and cobalt. There is a strong attraction between them and the what? Magnetic field. So when they are removed from the magnetic field, they still maintain their magnetism. So these are the three classes of magnetic material that we can see from the definition of the magnet, because we say magnet is a material that attracts a magnetic what? Material. So what are the magnetic material that can be attracted to magnet? These are the classification of them, and this classification is based on how all of them will respond when they get to the what? Magnetic field. So we are done with this now. So the next one we are looking at is classification of magnetic material. We are done with definition of magnets, classification of magnetic material. So very quickly, after this, let us go to method of making magnets. Method of making magnet. Now, if you want to construct magnetism out of a magnet, out of a material, what are the method? And if the material, you want the material to lose its magnetism, what are the method? So method of making magnet, meaning method of making a material to become a magnet. That's the meaning. So we have three methods of doing that. So method of making magnet. Number one, we have electrical method. I may not be able to explain this because of the time, but when you check your textbook, you see. So I can create a magnet from an object through electrical means. So electrical method. Number two, we have double touch. Let's say single touch. By touch method. I think I'm right. Touch method, yes. Then touch is of two types. We have the single and we have the what? Double. So these are the three ways of making a material to become a magnet. Put that material in a solenoid, there's something we call solenoid, and make electricity to run over that material. So put any of them inside the solenoid and make electricity to run over them. Then we can create a magnet out of that what? Material. So the material can be magnetized. That's the meaning. So for instance, iron, I want to make a magnet out of iron. What we need to do is to place that iron in a device called solenoid. So when you make electricity to run in a normal direction from the north pole to the south pole, then the material called iron will become what? A magnet. Then we have another method called touch. Here we need to touch that material with something we call compass needle. Yes, the material we want to change to magnet, we touch that material with what? Like for instance, iron. We rub that material with a compass needle. It may be a single one, a single touch. A single touch is just when one compass needle is used, while a double is when two compass needle is what is used. So all these three methods I've listed on the board, when you apply them to any of these one I've mentioned, then they become a magnet. So as we have a way of turning them to magnets, we have a way to turn them back to an ordinary iron, steel, or what? Cobalt. That one is called demagnetization. So method of demagnetization too is also three. Like we have three here. One of the method of demagnetization. What's the meaning of demagnetization? When you want the magnet to lose its magnetism, they become demagnetization. I have electrical method for that one too. Electrical method for that one too. Then I have mechanical method and I have heating method. Electrical method, so just like what you do here to run current over it in order to make it magnet. Now you run the current back, you reverse the direction of the current. Now when you reverse the direction of the current over all these magnetic material, you are making them automatically to lose their magnetism. So electrical method, that is by reversing the direction of the current on them, then they are losing their magnetism. Then we also have mechanical method. When you hit the magnet with a heavy object like hammer, big stone, you take a magnet and you hit it with a heavy object, that magnet will lose its magnetism. That method is called mechanical method. Then the third method is heating method. When you burn or you apply heat on a magnet, the magnet will lose its what? Magnetism. So that is how to create magnetism, how to explain magnetic material. So in the next video, we shall continue from factors that determine the magnetic strength. Thank you.